We are on to our last chapter of this marathon course with 19 chapters. This one is on local solutions. Basically, we already talked several times about how all global warming is actually local because we are experiencing local effects of global warming. Nobody is living in global warming temperature or global sea level and so on. So what is the advantage of thinking about locally is that they are place-based, so they take into account not just local weather and climate, but also local ecology, local human interactions, local cultures that may have evolved in that climate, weather, ecology context. And then there is the concept of bioregionalism, which basically looks at the interactions between everything local and the natural system with the human system. So solutions that evolve taking these into account become much more accepted because they are co-developed with the local system, local people, and local resources, and can serve local goals better as well. So we'll talk about localization and the concept of green infrastructure. Basically, infrastructure always refers to roads, buildings, hospitals, facilities, etc. So green infrastructure takes the local ecology into account for building systems to deal with the local extreme weather, local people's health, and local health of the soil, etc. Local health of the coastal water body or the lake that's there, and so on. And natural climate solutions, we talked about a little bit already, about how to use existing ecological conditions, environmental conditions to sequester carbon, mitigate climate, bend the curve, and how to localize the natural climate solutions we looked at. So we'll look at that again. And the concept of rooted university, which has got a strong link to the local community and develops its curriculum, its activities, its collaborations, its local environmental links in a place-based setting again within bioregionalism. So that becomes then a rooted university. So we'll talk about these things. The context in which we are talking about all these is, of course, what has already happened and what is expected to happen. This is a nice comprehensive diagram. Looks complicated, but we don't have to get scared. These are observed impacts attributed to climate change. Okay, so you can see the world map in the background, and you see different colors and symbols. Basically, they are corresponding to physical systems like glaciers, snow, ice, and permafrost, rivers, lakes, floods, and droughts, coastal erosion, and sea level effects. And in the green color, you have biological systems like terrestrial ecosystems, wildfire, marine ecosystems, and human-managed systems like agriculture, food production, livelihoods, health, and economics. So the bars you see on the side of each refers to the confidence in the depicted impacts based on all the data that IPCC could gather over the years. So the outline symbols here, minor contribution to climate change, and filled symbols are major contribution of climate change, not to. Okay, so the confidence intervals here go from very low, low, medium, high, and very high. So you can see that the impact on fisheries here, or biological systems, marine ecosystems, is very high here, here, and so on. The main thing to note is that if you look at polar regions, small islands, Australia, Africa, Central and South America, everywhere there are impacts on all systems, which can be attributed to climate change, which in turn can be attributed to anthropogenic or human activities, with various levels of confidence. Okay, some are low, like polar regions, the rivers, lakes, floods, and droughts. We don't have enough data, and so on. So that's the main point I would leave with. Every continent now has climate change impact detectable and attributable to climate change in the physical systems, biological systems, and human and managed systems. Okay, keeping that in mind, natural climate solutions, again to re-emphasize, can remove significant amounts of carbon from the atmosphere through better stewardship of natural and working lands. Remember, we have been talking about social transformation, regional tenets about whether we have dominion over the environment or we are stewards, and so on. And we talked about natural and working lands, enhancing carbon sinks into them, and so on. So this is a combination of localizing, worrying about bioregionalism, and how natural climate solutions fit into them. Green infrastructure incorporates the functioning of natural systems like trees, soils, waterways into human-built systems designed to improve environmental systems. For example, of course, stormwater management, flood control, ecological conservation, drought-resistant landscaping in the parks and other shared land in the public realm. Green infrastructure provides solutions to climate change through physical planning and design that integrates ecological systems, land use, and the built environment, which is what humans construct. Green infrastructure is included in a growing number of climate action plans already. So in the context of emission, that still means we have a long way to go, because these are not beginning to bend the curve yet, or not showing up in terms of reduced emissions yet. So we have to see what is the potential of these green infrastructures to reduce climate impacts locally. So this is always local, and how these local solutions add up globally. So CO2 is well mixed, long lasting, so it's like a global governance issue under IPCC, Paris Agreement, nationally determined contributions, etc. But the impacts of that greenhouse gas increase is always local in terms of extreme events, floods, droughts, sea level rise, biodiversity loss, etc.